Hello everyone, welcome to my channel. I am Amit Kumar Yadav. Today in this video we are going to perform Norton theorem by using an experimental. This Norton theorem comes under the basic electrical and electrical subject. But before starting this video, please like and subscribe my channel and also press the bell button for the notification, because all these things really motivate me for the new videos. Okay, let's. What is Norton theorem? It states that a linear active network consists of the independent or dependencies, and the various circuit elements can be substituted by an equivalent circuit consists of a current source in parallel with a resistor. The current source being the short circuited current across the load terminal, and the resistance being the internal resistance of the source network. That is, load current equals to short circuit current into internal resistance of the circuit upon internal resistance plus load resistance. Now here, what is IL? IL is your current across the load, your ISC is your short circuit current across the load, and here this RINT is your internal resistance across the load. Okay, now in the simple word we can say that this Norton theorem and Thevenin theorem both are almost same, both have same application, but the only difference is that in Thevenin theorem we just find out the Thevenin voltage across the load terminal, but in Norton theorem we just find out the short circuit current across the load terminal. That's why the formula of this Norton theorem get changed, but both the theorems Norton and Thevenin both are almost same. Okay, let us understand the Norton theorem with an example. In this circuit I have taken a single voltage source, I have load RL, and both are connected with some elements R1, R2, R. Now in this circuit I have IL, which is the load current across this R. So by using Norton theorem, what we have to do? We have to first calculate the short circuit current. Second, we have to calculate the internal resistance across the load. Okay, let's start the process for calculating the short circuit current and internal resistance. What is the process of calculating short circuit current? First, you just remove the load resistance and short circuit its terminal. After that, calculate the current whatever the flowing this terminal. Here it is denoted as ISC. ISC means short circuit. Now you can use any formula for calculating this ISC, but I have used the current division rule for calculating ISC. Okay, now in next step we will calculate the internal resistance. For calculating the internal resistance, what we have to do? You have to first remove the load terminal and just neglect the sources connected in the circuit. As you know that in our circuit we have a single voltage source which we have already short circuited. So this is your equivalent circuit. Now calculate the internal resistance across this terminal, and I have calculated this internal resistance here by using this method. Now after calculating the short circuit current and internal resistance, we have to convert this our circuit into the Norton equivalent circuit. Now what will be our Norton equivalent circuit? It will be something like this. You can see here the short circuit current source connected in parallel with the internal resistance, and both are connected across the load terminal RL. Okay, so this is the equivalent circuit diagram of the Norton equivalent circuit for this circuit, and from here we can say that the load current is equals to ISC into RINT upon RINT plus RL. So this is the final statement for the load current. Now in the second part of this video we are going to perform this Norton theorem in an experimental kit, and in that we are going to calculate some practical for calculating the experimental values, and after that we just compare that experimental values with the theoretical value. In this experiment we are going to perform Norton theorem. For performing this theorem we require this Norton theorem kit. We also require this multimeter and these patch cords. Okay, so let's start. In this practical, first I will close or I will complete this circuit one by one by using the patch cord. I just connect these terminals which are open. Now I have completed this circuit. In this circuit we have two sources, but performing this Norton theorem I am going to use only one source. So I am not going to take this terminal because in this terminal already there is one source also. So for neglecting this source, I am not going to use this terminal, and for performing this Norton theorem, I have taken this terminal as a load. Okay. So before starting this theorem, what you have to do, you have to first set the value of source. Okay. Now here in this circuit, I have taken single source, this E1. So first you have to set the value of this source. For calculating the value of this source, what you have to do, you just need to connect its terminals to the voltmeter. Okay, so just connect its positive terminal with voltmeter positive and its voltmeter negative with the negative of this source. Okay, supply on the circuit. Look here, there are some values are coming. It is coming around 9 volt. Okay, so in this circuit we have source E1 whose value is 9 volt. Okay, now switch off the circuit. After calculating the value of E1, you have to calculate the value of equivalent resistance across this load terminal. Okay, so calculating the equivalent resistance across this load terminal, what you have to do, you have to first disconnect this load from the circuit, and now you have to calculate or equivalent resistance across this terminal. But for calculating equivalent resistance across this terminal, you need to neglect the sources connected in the circuit. Now, as I have told you earlier, in this circuit we have one source only. So for neglecting this source, you have to just short circuit its terminal like this and use this multimeter, set it into ohm. I have set it into 2000 ohm. Now just measure value of equivalent resistance across this terminal. Okay, I have already disconnected the load terminal and I have already short circuited the voltage source. Now just measure its value. It is coming around 395 ohm. So this is your value of equivalent resistance across the load terminal. After this, we have to calculate the short circuit current across this terminal. That is your short circuit current ISC. For calculating short circuit current, you have to just calculate the current between these two terminals. So for calculating the current, means short circuit current between these two terminals, you have to just connect this ammeter in between these two terminals. So before connecting this, you have to just reconnect the source again with the circuit. Okay, so for calculating the current, I am going to use this multimeter. Just connect it positive here, negative here, and set this multimeter into current. I have set it into 20 milliampere. Now supply on the circuit. It is coming around 3.15 milliampere. After this, I am going to calculate actual load current across this terminal, because whatever the short circuit current and RTH you have calculated, use these two values, put it into the formula and calculate the actual IL. But what happened? You have to check whether that measured IL is matched with the actual IL or not. There may be some percentage of error. It will be around 5 to 10%. So for calculating the actual load current, just connect the load terminal with the main circuit like this. Now for calculating the current for this load terminal, what you have to do, just remove these two terminals, connect the positive lead here, negative of this multimeter here, and supply on the circuit. It is coming around 2.6 milliampere. Okay, so this is your actual load current. Now after this, I am going to just calculate the error between calculated, means actual practical current, and calculated theoretical load current.
for the percentage error.
Now after this experiment we can see that we have set the source voltage approx 9 volt, and these are the values of resistance connected in circuit, and in that circuit we have taken a load terminal whose value is 184 ohm. Now in this part we are going to see what is the difference between the values of theoretical and experimental reading which we have conducted in our experiment. So here you can see that here load resistance is same for both the case, theoretical and experimental values, but in the case of theoretical values internal resistance is here 388 but experiment value is 395, which is slight different from the theoretical. Here theoretical ISC is 3 milliampere, experimental is 3.15. Here your theoretical IL is approx 2 milliampere but the experimental IL is approx 2.15 milliampere, and I have calculated these load current by using this Norton standard formula. Now in this part we are going to check how much error in between theoretical and practical. Here theoretical load current is your 2 milliampere and your practical load current is approx 2.15 milliampere. So for calculating the error percentage I have used this formula and it comes around 7%. So question is why this error occurs? So answer is that these error occurs just because that in theoretical case we are not going to consider the internal resistance of the circuit, but in practical case we are going to consider the internal resistance of the circuit also. And one more thing is also that in practical case we use some measuring instrument and these measuring instrument may have some percentage of error. That's why this 7% of errors comes in between theoretical and practical value. Hope स्टूडेंट्स आपको ये हमारा ये वीडियो समझ आया होगा और मुझे पूरी उम्मीद है कि आपने मेरे चैनल को लाइक एंड सब्सक्राइब जरूर कर दिया होगा. ओके, थैंक यू फॉर वॉचिंग माई वीडियो. थैंक यू.